All right, so if my claim was something like this here. Okay. So first off, how do you write that in math? There it is in English. How do you write that in math?
Less than or equal to something.
What is? P. So P at most means less than or equal to. I like it. At most means it can be less than, but up to. So which one is that going to be? Yeah, why is it going to be the whole? Because it has an equal sign. I love it. Something you guys never knew about. The whole. The high is going to have to be the opposite. So notice how you write the claim. You step back. Does it have an equal sign? Okay, it goes in the ho. Does it not have an equal sign? Okay, then it goes in the high. And then the other one is the opposite. That's why you're guaranteed that the ho will have an equal sign. You guys kind of see that? So then this is going to be, of course, greater than 0.11. How many tail tests will it be? 1. And where's the test? Where's that tail going to be? Where's the tail going to be? Exactly. That way. Why up there? Because the tail, the rejection region is always set up by this dude. It's not always set up by the claim. It's always set up by that dude. Because that's the one that I can actually show evidence for. I can never prove that it equals something by using a sample. I can only show evidence that it's away from something else. It's far enough away from some other value. That's why this always sets up the rejection region, however many tails it is. So the very first thing I worry about is the claim, and then I don't think about it again until the very end. So if the claim was this instead, the mean has changed from 11. So the claim is the mean has changed from 11. So how do I write that in Mathish? Not equal to. Yes, it's changed from 11. So it's not 11 anymore is my claim. I think it's not 11 anymore. So I think the mean is not 11. How are we doing there? Is that so? If it says we think it's different now, we think it's changed, that's not a specific increase or decrease. It's just we think it's different. So what's different mean? Not equal to. So which one is that going to be? It's going to be the high because it's got the exact opposite of an equal sign in it, right? And then the opposite of that, of course, is equal to. Sweet. And how many tail tests will that be? 2. And then you can't go wrong about where they are. Although maybe somebody will. I don't know. It'll be very creative. All right. Is that cool? Is that related to the question somebody asked me?
Would you like to reject that?
Yeah. So here, let's say that we don't get far enough. Let's say we get there. What does that mean about what can I immediately say if I get here, if I don't get it into the rejection region? What can I say? Fail to reject. The what? Fail to reject the ho, fail to support the high. I like it. And specifically for this one, what language would I use to start writing the conclusion? Which one was the claim? The ho, so then I use this language. We have not found sufficient evidence to reject the claim that the percentage is the most 11%. If I didn't make it far enough away. Is that cool? So over here, same thing. What if I made it in there? Over there, this one. What if I got a sample that was so far below it? Okay. All right. What can I say then, real quick, little tiny phrase? Let it out. It's okay. Let it out. There you go. There you go. Okay. Please be. So if I get in there now, what can I say? No, real quick little phrase. Little tiny phrase. If I get in there, you can always say we reject the no, support the high. Specifically here, what language would I use? What was the claim? Which one?
The high.
The high. So I'm going to use this language. We have found sufficient evidence to support the claim that the mean has changed from 11 years, different from 11 now. Is you okay? Did you notice? I don't know if you're still coughing. That means she's breathing still. It's good. To breathe, to be able to cough. Yes?
So that language on the left is always going to be used for the outcomes.
The minute, always, no matter what the hell else is going on, if you don't make it into it, whatever the rejection region is, if you don't make it, whatever it is, if it's 2 tail, 1 tail, who cares? If you don't make it in there, this is true. Always. I don't care what the hell's going on. If I don't make it into the rejection region, I failed to reject the no. Kind of makes sense. You guys kind of with me? So I can always say these, and then I step back and I see which one was the claim, and I use that language. If I make it into the rejection region, whatever the hell it looks like, and whatever the hell's going on, I can always say these two things. And because that's why we called it the rejection region, because if I make it in there, the middle, the one that has the middle, that thinks that the middle is true, can't be right. So this one looks like he's right. So then I can use this language in this case. Yes?
Is the rejection region the same as alpha, or that's completely different?
Yeah, I think I call it the rejection region. The book uses the critical z-score, or maybe they call it the critical region. I always forget. To me, it's better just to call the damn thing the rejection region, because what do you do when you get in there? You reject the null hypothesis. Yeah. If you don't, you fail to reject the null hypothesis. You got to love that shit. And the whole thing is, I really, really dislike trying to teach you guys to memorize stuff like that. Just why the hell does this make sense? If I don't get far enough away from the middle, then I haven't shown evidence that the middle is wrong. So therefore, I can't say that the one that has an equal sign is wrong. I can't. I fail to say he's wrong, because I didn't get far enough away to say it doesn't look like that's the middle. That's why that's the connection. If I do get so freaking far away from the one that says that's the middle, then it looks like he's wrong. I'm so freaking far away. This can't be the middle. So then that's why I can reject this guy. The one that thinks the middle is here, I can reject him. I can reject the null. And which one always has the equal sign? The freaking null. So that's why we set it the way we do, so we can just do these standard things once we get to the end. All right, maybe. Okay, good. I'm glad you're back. Okay. So here, if this is my rejection region here, and I get there, what can you say very quickly? Fail to reject the hope. Which means you also fail to support the hope. Because the hoe thinks the middle is here, and I got really close to it, so I can't say he's wrong. It looks like you might be right. And then you step back and you say, well, which one was my claim? I'm going to use that language. That's the only next time you care what the claim was, is at the very end. Okay, I like it, maybe. Okay. Anything else from homework or general questions? Or?
So the hoe is always kind of like a medium, or
The hoe always has the equal sign in it, so it's the one that kind of thinks it should be here close to this.
Okay.
So that's why it's the one I reject, if I'm so far away from there. I fail to say it's wrong. I fail to reject if I'm not far enough away from there.
And then the high is like the experiment.
The high is the one that thinks it's out here somewhere. And that's why I support it if I get way the hell out there, and I fail to support it if I don't. I like it. The idea is there. It actually makes sense, believe it or not. Seeing your faces, you're like, I don't know if you know what that word means, Jeff. After yesterday, I'm not sure I know what it is, actually, either. All right. So anything else from homework or other general questions? Okay, because I want to finish up that handout from the other day, the other side of it. I'm going to let you guys work on another one by yourselves. Did any of you guys go vote? Yeah? Did any of you guys stay up late last night? That was me too, man. And I'm like, I should have just pretended, and so I could have gotten some sleep. I don't know where you're, who you voted for or anything, so I'm always very cautious about putting my own political beliefs out there, but it's very difficult for me to hide them right now. So obviously I'm upset about yesterday. But the reason I don't want to put it out there is if somebody has a different opinion than me, they might think that I'm not going to treat them fairly in the class, and that's bullshit. I'm professional. I'm going to treat everybody. You're going to get the grade you earn. I'm a human being, though. I've got my own opinions about things. And yesterday was such a big day, it's hard for anybody to contain their emotions about what happened. But that's all I want to talk about that, to be honest. I want to try to continue pretending like it didn't happen. Yeah, it's a nightmare that you never wake up to. I want to show you real quick. I'm not intending for you to try to understand everything in this article. I just found this article. It's a recent article. It actually is, they found genes that are related to dreaming and deep sleep, which is kind of nifty. And this is what the title looks like when you go to the journal, so you kind of lose what the hell the purpose was. Forward genetics analysis of sleep in randomly mutagenized mice. Okay, sounds like, giant mice are going to come roaming around the earth, and that should be interesting. Well, I just want to show you one thing. There's a lot of science in here that I don't understand half of the damn science, so I'm not going to expect you to. But I want to show you those things that do make sense. So one thing they need to do when they're doing this study is they need to show that there's no differences between two different groups. So if I wanted to give one group one drug and the other group another drug, I want to test to see that there's not major differences between them that would affect the outcome. Does that kind of make sense? If I have a whole group and none of them have ever had coffee in their entire life, that might affect my analysis. Are you guys kind of with me? So what they did here, notice this, the p-value. What's the p-value? Does it have to be big or small for evidence to have been found, for me to make it into the rejection region? Let me see if you guys are to the point where you can answer that question. The p-value is what? What is the p-value? The area in our tail, right? So if we get into the rejection region, is our tail going to be big or small compared to the rejection region itself? It's going to be small. So small p-values mean there is a difference that was found. And what do I want? I want to show that there's no difference or no significant difference, so I can continue with my analysis. And see, this is what they did. If the mouse had some trouble sleeping, the mouse got to breed with some kind of specific kind of female mice. And then they checked to see if they had similar sleeping habits. And because the p-values are all pretty damn big. These are huge, right? Normally I want less than 0.05 or less than 0.01, right? Those are the alpha values. Are you guys kind of with me? And these are huge, which means there's no difference that was found. They're like really close to the mean. They're not far away from it. All right, so we can kind of tell. You should be able to start seeing stuff like there. What is this? Confidence interval. Kick ass, right? And somewhere they said, oh here, look, holy shit, two-tailed student's t-test. Right, so, and this is I want you to realize the work you're doing is the pretty much the exact same work that goes into a study like this. All right, maybe. If I scroll a little bit further down, I found one that sort of makes more sense. Was it this one? Oh my God, no. Which one makes sense? I was trying to find one for us. No. Super mutant mice itself. Holy crap. Oh well, I can't. Shoot. Where did it go? Oh yeah, it is this one. Okay, there it is. So this is what they did here was they changed the cage. They took them from the home cage and they took them to a new cage, and then they analyzed any difference in sleep. And did they find evidence of difference? Yes, the p-values are really, really small. And, you know, some of us might go, well, duh, but they want to know the power of that difference, so they can tease it out as a variable and control for it when they want to do other things. Does that kind of make sense? So they want to analyze this from all these different perspectives, and these p-values give an idea of, is there a difference when you do this, or is there not a difference when you do this? So you know how to move forward. Okay, how we doing? I always want to try to find something in the real world, and I know that this is nothing that we're too heavily connected to. How well do mice sleep? Right. But this actually, anything they do with mice eventually works its way to humans, because, believe it or not, we are very genetically similar to mice in a lot of different ways. Right? Okay. Enough of that one. Let's go to this handout now. Okay. Oh, let me do this. Let's talk a little bit about the idea here before we jump into it. So we did the reverse of this last time. What we're getting into now is what's a little bit not real life yet totally, is that normally when I do a hypothesis test, I'm checking between two samples. So when I do a drug test, I have a sample of people that get the drug, and I have a sample of people that don't get the drug. They get something else maybe. You guys kind of with me? So I want to compare two samples to each other. I don't want to compare one sample mean to a known mean. I want to compare one sample mean to another freaking sample mean. Right? So what we do is we take this formula. Now I'm going to write the bottom here. Let's see. Let's play with the bottom a little bit. I'm going to try to show you where this formula comes from. Yes, sir? Yeah, this is chapter 10. I like it. Oh, yeah. Shit just got right. Who remembers what's happening next time before I go too far? Another quiz. Oh, my God. Oh, yes.
Chapter 9.
It's going to be on hypothesis tests. Nothing too insane. It's going to, and you're like, well, hypothesis tests by themselves are insane, John. I'm going to give you all the steps. I'm not going to make you remember all 5 steps yourself. I'm going to ask you question, just like the handouts. Help me out. What's the formula for this guy again? Not sigma. It's got to be S. You're like, man, so picky. Now watch. Now watch. Go with me. Can't I write this? Now these can't really interact because they're not both under a square root. So we're not going to get all the way into the derivation of this formula, but I want to point out why the formula makes sense. Right now, how many samples are in this formula? One. I only see one mean. I got to double everything so I can put two means in there and two standard deviations in there because I'm going to have two different samples that I'm comparing. So one thing we do is we force it. Now, if I put one big ass square root, what is s the square root of? What is s the square root of? S squared. I love it. The variance, s squared. All right, let me just leave that there for a second. If you guys agree with me, you're like, you're the math man. But does it make sense to you? I could always go insane and just start writing gibberish up here. And you're like, that started happening about 3 weeks ago, right? All right, now watch. This is kind of cool. So I'm going to take one sample and a second sample, right? This is the way this kind of works. And I'm going to get x bar 1 and x bar 2. That's amazing. And there could be like the women versus the men, for example. And the women might have a different population mean, and the men have a different population mean. Everything's kind of doubled. So this formula becomes... I need x bar 1 minus its mean, not plus, get out of it. Let me write it like this. Let me just write it more close to what it's going to be. X bar 2, all right, you guys with me? Minus mu 1 minus mu 2. I like that. Oh, I'm sorry. This will be, I don't want to write this. Yeah, like this. Sorry, put a little plus there. All over now. So I'm going to take that expression for the single sample standard deviation. I'm just going to double everything in there. So I'm going to have S1 over N1 plus S2 over N2 squared, right? It's got to be that variance inside there. So it's the same formula. I understand the opinion that this is awful. I understand. But it's the same exact formula, just everything's been doubled. And what's really beautiful, especially for us at in Stats 1, is that normally the null hypothesis is going to be that these two are equal. So if I'm trying to show evidence that my drug is better than the old drug, that's going to be my H1. I want to say that it takes pain away faster, stuff like that. You guys with me? So then the null hypothesis is that, like always, it's going to have an equal sign in it. And if mu1 equals mu2, what is mu1 minus mu2? 0. I love it. So really this formula becomes how far apart are the sample means, and then I divide it by the standard deviation to see how relatively far. Is that far apart enough? So I'm still going to have the same steps to begin with, right? What's my hypotheses? What do I claim? My hypotheses. What can I use? The rejection region is going to be set up the exact same way. There's one little difference, though. You might be worried, what is it before I can find like the rejection region? I'm going to be an alpha. If it's a t-score I'm using, what else do I need to know before I can use the t-chart? Degrees of freedom. And now that I've got freaking 2 sample sizes, there actually is a rather disgusting formula that's in the book, but there's an alternate way that's normally accepted to find the degrees of freedom. Yeah. So the N1 plus N2, that's sort of like a total sample size. Like if I take a sample of men and a sample of women, then N1 plus N2 is just a sample of people that I took. Minus 2 is sort of like minus 1 for each one, so it's minus 2 total. All right. Every step is still the same, except I use this formula on step 4, and that looks so yummy. And I use this idea on step 3 to help me figure out what the critical score is, how far away I've got to get. All right. So with all that in mind, yes, sir.
So when you're dealing with 2 sets of data, you're still applying it to one.
I like what you're asking. Yeah. Because what it becomes, especially with this, what it becomes is I have, I'm thinking the middle is 0. Like the difference is 0.
Okay.
And I'm trying to show that the difference is far away from 0. Does that make sense?
Yes.
Okay. I want to show that these two samples are so far apart from each other. So if the means really are equal, then if I take a sample from one and a sample from the other, they should be close to each other. Therefore, their difference should be close to 0. And I'm trying to show that the difference is actually far away from 0, meaning one is way bigger than the other one or vice versa.
So then that means this test is mostly to prove that you need 2 different sets of...
If I have 2 different samples, this is what I have to use to do it.
Okay.
Right? So this guy requires me to know something about the population itself already. And if I go into something with this brand new drug, I'm like, I don't know shit about it. So there's nothing here I can do. I'm just going to assume that it's the same and then try to show evidence that it isn't. Right? So that's why that goes. I assume that they're the same. That's what we always do in hypothesis tests. Yeah, assuming that the mean is this. I'm going to try to show evidence that it ain't. That it's so far away from that it isn't the same. Yes, ma'am.
So why did you toss out mu1 minus mu2? Is that what we're trying to
Because the null hypothesis
Okay.
will always have that equal sign.
Okay.
Therefore, these two will cancel each other out. Now, to be honest, in other kinds of studies, you could actually say, I think the difference between these is 9, and then you just put 9 here.
Okay.
But for right now, I don't want to go there. I want to keep this closer to what we were doing before. And the book kind of agrees with me too. We sort of say this is almost always going to be true, so we might as well just make that go away. All right. So let's try one. And I'm going to need your help for it because has everybody got this handout here? The one with females and males and a bunch of grades next to them? Woo! All right, so take a minute. And I need information from you for step D, right? Can you guys put the data into your calculator and find the sample means and the sample standard deviations and all that stuff so that we have it there ready for us for step D? Thank you. You're so nice.